Okay, so what we did yesterday, if you weren't here yesterday, is I'm going to go back to the top where we started. We did just the odds of exercise 7.3.1. We're looking at division and finding zeros of polynomial functions. And it told us to use rational zeros theorem to make a list of possible rational zeros. So you take your number, your constant on the end, and find its factors. And then you take the coefficient to the leading term, the leading coefficient, and you find its factors. And then you do P over Q to find all your possible zeros. So that's the first thing we did yesterday, just find possible zeros. Then the next section asks us to find real zeros, which if you have something to the fourth where it's 4, 2, and 0, if you have a third in there, if you have a single x in there, you'll have to do a different method. But if it's 4, 2, and negative 15, you can try to factor it like you would a quadratic. This one happened to work. And remember, this one was asking us to find real zeros, so that's why I didn't count this one, because it was an imaginary or a complex zero. If you have to the third power or to a fourth power where you have extra things, so you can't factor it, then you get to use that possible zeros method where you find the factors of the constant, the factors of the leading coefficient, and then you have numbers to guess, and then you just kind of go through and just guess until it works. Super fun times. Okay? And again, we just looked for real answers yesterday. We didn't look for imaginary. So today, we're going to find all the zeros of the polynomials, and then we're going to completely factor over the real and complex numbers. Okay? So when I look at this first one, it's x cubed. So it's a cubic function, which we do have our perfect cube formulas, but I know this one's not going to work because while x to the cube can be cube rooted, 5 is not a perfect cube. So I'm going to have to just guess and check until I find a number that works. Okay? So remember yesterday that we said the first thing that we do is we say, okay, A0, my constant on the end, is 5. So that means my values of P are going to be my factors of 5, which are 1 and 5. It's a prime number. That's all that goes into 5. Then we looked at the leading coefficient, and we call that A sub whatever the degree is. This is 3, which in this case, if there's no number in front of the leading term, we know that means the coefficient is 1. And the factors of that number give us our Q value. So the only factor of 1 is 1. Then we use our P and our Q to find our possible zeros. Our possible zeros are all the factors of P divided by Q. Okay, so that means I can put 1 over 1, which is just 1, or I can put 5 over 1, which is 5, and then it's the positive and negative of each of those. Positive, negative, positive, negative. So I have 4 things to try. 4 things to try. And what I did yesterday is I just started with, okay, let's just start with the smallest ones and work our way up. So I just started with 1. And I said the first thing I'm going to do is divide by 1. And I use synthetic division because I just want to know, does it have a remainder? If it's a 0, it won't have a remainder. Then I look here and I go, okay, this is 3, 2, 1, 0. So I have all my coefficients. So I just use the 1, the 6, the 6, and the 5. Make sure if you have any negatives, that goes with it. And I use this and do synthetic division. My goal is to have a 0 under the 5. For synthetic division, just to review real quick, remember your first number just drops down. And then you always multiply this number under here to over here. So 1 times 1 is 1. Add these two together. 6 plus 1 is 7. Multiply. 1 times 7. Add. Multiply. Add. Since I don't have a 0 here, that tells me that x does not equal 1 as a solution. So then we can try -1. I'm going to do the exact same process. I'm going to try to divide the equation by -1. So I have a 1, a 6, and a 5. My 1 comes down. -1 times 1 is -1. 6 minus 1 is 5. -1 times 5 is -5. 6 times -5, or 6 minus 5 is 1. And -1 times 1 is -1. So that's 4, which is not 0, and we're looking for 0, so that one doesn't work either. X is not -1. That doesn't work. So both positive and negative ones, those are not solutions. Now we still have positive and -5. So I'm going to try +5. 1, 6, 6, and 5. Again, remember, those are just the coefficients from the original equation. 1 comes straight down. 5 times 1 is 5. 6 plus 5 is 11. 5 times 11 is 55. Plus 6 is 61, which is 305. So that's 310. That's way too big. So 5 doesn't work. So -5 either has to work or we can't solve this problem. So let's hope -5 works. If -5 doesn't work, that means there are no real solutions. It never crosses the axis. Okay? 1, 6, 6, and 5. My 1 comes down. -5 times 1 is -5. 6 minus 5 is 1. -5 times 1 is -5. 6 minus 5 is 1. -5 times 1 is -5. 5 minus 5, hallelujah, it's 0. So that means -5 is a 0. X equals -5. I'll write that better. Is a 0. And we are also going to have to eventually factor it over the real and complex numbers. So as a factor, remember your factor is x minus the solution. So when I do x minus a -5, it's really x plus 5 as a factor. Does that make sense to everybody? Some sort of head nod, thumbs up, something? Yes? Okay. All right. So that's just 1. Since this is to the 3rd power, I should get 3 answers. To get the other answer, we look at our result over here. I have 1, 1, 1. And remember, if this was x to the 3rd, then when I rewrite my next equation, I start with squared. So now I'm going to do x squared, 1x squared, plus 1x, plus 1, x to the 0 power, which we just put it as 1. So now I need to factor that. However, if I try to factor this, if you're writing down, if you're following along, I would not write this because it's not going to work. If I try to factor this and I put my a times c, a +1, and my b is a +1, the only factors of 1 are 1 times 1. But there's no way to get a 1, right? If I add those together, I'll get a 2. If I make them both negative and subtract them, I get a -2. So this is not factorable. Okay? If it's not factorable, I'm going to erase this out because it wasn't factorable. I told you not to write it down. Okay? If it doesn't factor, then we use the quadratic formula. Because that's the only thing left for us to do. Okay? So remember your quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative b is 1, negative 1, plus or minus the square root of b squared, so 1 squared is 1 times 1, that's just 1, minus 4, a is 1, c is also 1, all over, 2a, a is 1. Negative 1 plus or minus the square root of negative 1 minus 4 times 1 times 1. Sorry, 1 minus 4 times 1 times 1. 4 times 1 times 1 is 4. Over 2 times 1 is 2. Negative 1 plus or minus the square root of 1 minus 4 is a negative 3 over 2. I'm going to divide this into the two fractions. So I'm going to divide this into negative 1 over 2, so negative 1/2, plus or minus the square root of negative 3 over 2. That negative can't stay in the square root. Do you remember what it comes out of a square root as? I. So this is negative 1/2 plus or minus the square root of 3 over 2i. That's my other solution. Well, those are my other solutions. There's two, right? Because there's the plus and the minus version. Okay. So remember what this asked me to do? It said to find all the zeros. My zeros are x equals, we said the first one was x equals 5, right here, x equals or negative 5. And then these two. The first one is negative 1/2 plus the square root of 3 over 2i. And the second one is minus 1/2 minus the square root of 3 over 2i. So there's my zeros. It wanted me to do one other thing. It said to factor over the complex and real number, completely factor. So I've already factored using the x equals a negative 5. Remember, when you put it inside the parentheses as the factor, it's x minus a negative 5, so that becomes x plus 5. We do the same thing over here. We're going to say f of x equals, we know one factor is x plus 5. Then it's x minus the next 0. Now, when you subtract this whole thing, you need to subtract the negative 1/2, and you need to subtract the square root of 3 over 2i. So when I subtract the negative 1/2, when I subtract the negative, what happens when you subtract a negative? When you subtract a negative, what happens? So I'm going to have x plus 1/2. And then it's really plus here, but I'm subtracting it. So it becomes minus square root of 3 over 2i. That takes care of my second 0. And then I still have my third 0, which is going to be x minus a negative 1/2. So minus negative 1/2. And then minus a negative all of this fraction. So minus a negative means plus square root of 3 over 2i. This is the completely factored form. Those are my zeros. That's the completely factored form. It's a lot, I know. Take a minute, see if you have any questions. There's the whole thing. Questions? All right, we do the same. Well, actually, the next one's easier because the next one is x squared, which means I don't have to do all this guessing. Anytime it's an x squared, I can go straight to the quadratic formula, right? Unless it factors. You could check to see if it factors. I have a 13 on the end, a 1 in the front, so 1 times 13. So I'm looking for a positive 13 when I multiply, and a negative 4 when I add. But the only way to get a positive 13 is 1 and 13, and there's no way to use a 1 and a 13 to get a 4. So it doesn't factor, which means I have to use the quadratic formula. But that's okay. We can do that. Negative b is negative 4, so negative 4 becomes a positive 4. Plus or minus the square root of b squared. Negative 4 squared is a positive 16. Negative 4 times negative 4. Minus 4ac. A is 1. C is 13. All over 2a. A is 1. So that is 4 plus or minus the square root of 4 minus 4 times 1 is 4. 4 times 13 is 52. 2 times 1 is 2. So this is 4 plus or minus the square root of 4 minus 52 is 48. Yes, did I do that right? I see a confused face. What did I do my math wrong? Okay. Did I do some math wrong? Yes. It would be a negative. Good. All over 2.
Shouldn't that be a 16? Yeah, like 16 minus 52.
Oh, right, because it's b squared, and it was 4, so that should be a 16. Thank you. I was going to say, that's not what I got in my last class, and nobody's yelling at me. All right, so remember it's 16. I wrote it correctly here, and then I don't know what happened when I got over here. 16 minus 52, what's 16 minus 52? 36? Negative. So this is going to become, when I separate it, well, we can wait to separate it. 4 plus or minus the negative square root of 36. What's the square root of 36? 6, but it's really 6i because it's a negative 36. All of this is over 2. 4 divided by 2 is 2 plus or minus 6i divided by 2 is 3i. So this is a squared function, which means it has 2 solutions. One solution, or 0, is x equals 2 plus 3i. And the other one is x equals 2 minus 3i. My factored form, so that's one, those are my zeros, and then it also wants us to write the factored form. My factored form is f of x equals x minus this whole thing. So I'm going to take away the 2 and I'm going to take away the 3i. Minus 2 minus 3i times x minus, I'm going to take away this. I'm going to take away the 2. I'm going to take away the negative 3i. Take away the 2. Take away the negative 3i. So when you take away a negative, it turns to a positive. That is my factored form. Questions on 31? We're good on 31. We're ready to go to 33. Okay. 33, again, I have a square. I love squares because squares are easier to work with because I can just go and look to see, does it factor? If it doesn't factor, then quadratic formula. So the first thing I'm going to check is, does it factor? So in order for it to factor, if I take the 3 and the 10 and multiply them together, I get 30. And then I want to get a 2 here. So my factors of 30 are 1 times 30, 2 times 15, 3 times 10, 4, 5 times 6. Is there any way to get a 2 out of those? No. So that means it doesn't factor and I get to use quadratic formula. Okay, quadratic formula says negative b, so negative 2, plus or minus the square root of b squared, so 2 squared is 4, minus 4a, a is 3, c is 10, all over 2a, a is 3. So this is negative 2 plus or minus 4 minus 4 times 3 times 10. 4 times 3 is 12. 12 times 10 is 120. Divided by 2 times 3 is 6. Negative 2 plus or minus the square root of negative 116 divided by 6. So first I'm going to simplify off to the side. I'm going to come over here and just figure out 116. I want to simplify it. I don't think it's divisible by 16, but it's definitely divisible by 4. 4 goes into 125 times, and there's 16 left. 4 goes into 16 4 times, so 29. 4 times 29 gives me 116. Does everybody agree? What's the square root of 4? What times what makes 4? 2. 29 is a prime number. There's nothing that goes into 29. So that's as much as I can simplify this. But we're not looking at the square root of 16. We're looking at the square root of negative 16. So this is really going to be 2 square roots of 29i. So I end up with negative 2 plus or minus 2 square roots of 29i over 6. And now I'm going to divide it into my two fractions. Negative 2 sixths plus or minus 2 square roots of 29 over 6i. And then I'm going to reduce. What's 2 over 6? Negative 2 over 6 reduces to negative 1/3. Plus or minus, then the same thing happens here. That 2 over 6 reduces to 1/3. If there's 1 in front, you don't have to write it. So square root of 29 over 3i. So my solutions, or my zeros, are x equals negative 1/3 plus the square root of 29 over 3i and negative 1/3 minus the square root of 29 over 3i. Those are my zeros. My factored form is f of x equals x minus both of these things. So when I do x minus a negative 1/3, it becomes x plus 1/3. Minus this second fraction, the square root of 29 over 3i. That's my first factor. My second factor is x minus all of this. So I'm going to subtract the negative 1/3, which makes it a positive 1/3. And then I'm going to subtract the negative square root of 29 over 3i, which means if I'm subtracting the negative, I'm really adding it. So there's my zeros and my fully factored form, my completely factored form. Good times. All right, the next one, number 35. Are we ready to go on? Number 35 is unfortunately not a squared, so I can't just go straight to the quadratic formula. I'm going to have to check it for cubic polynomials. So if I look at my cubic polynomial functions, my perfect cubes, it's not going to match because while I can cube root x cubed, I can't cube root 12. There's nothing that multiplies to itself 3 times to make 12. Which means I get to do the fun guessing and checking. Yay, guessing and checking. It's so fun. Okay, so I'm going to start with my last term, my a sub 0, which is going to be 12. So that's going to have a lot of factors. My p is going to be 1, 2, 3, 4, 6, and 12. All of those can divide 12 evenly. Then my a sub, in this case, my leading degree is 3. So a sub 3 is 1. That's helpful because that means q can only be 1. So my possible zeros are the p's over the q's, the positive and negatives. So it's going to be 1 over 1, 2 over 1, 3 over 1, 4 over 1, 6 over 1, and 12 over 1, and it is the positive, negative of each one. Anybody have any specific ones they want to try, or you just want to start at positive 1 and work our way down? Okay, let's start at positive 1. So if I start at 1, since there's so many to choose from, I'm going to start way over here. My coefficients, I have 3, 2, 1, 0. So I've got my coefficients are 1, 3, 4, and 12. The 1 comes straight down. I'm going to zoom this in just a little bit so y'all can see what I'm doing here. The 1 comes straight down. 1 times 1 is 1. 3 plus 1 is 3. 1 times 3 is 3. 3 plus 4 is 7. 1 times 7 is 7. And 12 plus 7 is 19. So that doesn't work. Now, here's kind of something to look at. If all of these are positive, then as I multiply by a positive number here, everything's going to stay positive, so you're just going to keep on getting bigger. So if I know all of these are pluses, I'm probably going to need to multiply by something negative, right? So that I could eventually get down to 0, because I'm going to need to want to have a negative 12 here. Does that make sense? So let's try our negatives first. We'll start with -1, now that we already found out +1 doesn't work. All right, so I'm going to go like this, and I'm going to do 1, 3, 4, and 12. My 1 is going to come straight down. -1 times 1 is -1. 3 minus 1 is 2. -1 times 2 is -2. 4 times -2, or 4 minus 2 is 2. -1 times 2 is -2. So that becomes 10, which is still not 0. But we got closer by using the -1. So it's not positive or -1. You want to try -2? We know the positive's not going to work, right? Because that's just going to keep on getting bigger. So let's try -2. I'm going to have 1, 3, 4, and 12. The 1's going to come straight down. -2 times 1 is -2. 3 times -2 is, or sorry, 3 minus 2 is 1. -2 times 1 is -2. 4 minus 2 is 2. -2 times 2 is -4. So that's going to be 8. We got a little closer, but still not a 0. So I know +2 is not going to work. I know -2 now doesn't work. Let's try 3, -3. 1, 3, 4, and 12. My 1 comes straight down. -3 times 1 is -3. 3 minus 3 is 0. -3 times 0 is 0. 4 plus 0 is 4. And -3 times 4 is -12. It worked. Whew. So now I know that x equals -3 is a solution, which means x plus 3 is a factor. Okay? So then when I take the 1, 0, and the 4, I can use that to figure out that it's going to be 1x. If this was to the third, then this is going to be squared, plus 0x's plus 4, which you could rewrite as 1x squared, so just x squared, plus 0x doesn't have to be written, and then plus 4. That, we can solve that for 0, right? If I'm just trying to find the zeros, I could do the quadratic formula where a is 1, b is 0, and c is 4, but I can solve this. I can do x minus x squared plus 4 equals 0. If I only have an x squared, I don't have an x, that's pretty easy to solve. How do I solve this? How do I get the x squared all by itself? Yeah, subtract 4 on both sides. So x squared equals -4. How do I get rid of the square? Square root, because my square and my square root will cancel. So I end up with x equals, since I have a negative, I know I'm going to have an I, and the square root of 4 is 2. And it's, since it's a square root, it's the plus and negative of that.
Wait, how'd you know there's going to be an I?
Because there's a negative inside the square root.
Oh.
Anytime you square root a negative, you get an I. All right, so we're done. My solution, well, we need to write our answers. My zeros are x equals -3, because that one worked over here. And then 2i and negative 2i. To write the factored form, we say f of x equals x minus a negative 3. Minus a negative is a positive. X minus 2i and x minus a negative 2i. Minus a negative becomes positive. There's my zeros and my completely factored form. Questions on 35? All right, we still have 12 minutes. I think we can get 37 done. All right, f of x equals negative 3x to the fourth minus 8x cubed minus 12x squared minus 12x minus 5. Whew. All right, so we need to figure out what our possible zeros are so that we can figure out a rational zero. A sub 0. What am I going to choose for a sub 0? Which number do I look at? Yeah, and we don't care about the sign. We just want the 5. And the factors of 5 are just 1 and 5. So my P is 1 and 5. Then my a sub, I have a degree of 4. Oops, I didn't switch colors. I wanted to. A sub 4 is going to be what number? 3. And the factors of 3 are my Q values. So that's going to be just 1 and 3. It's nice when they're prime numbers. So then my possible zeros are going to be my possible P's over Q's. So that's going to be 1 over 1, 1 over 3, 5 over 1, and 5 over 3. It's the positive and negatives of each of those. So there's 8 possible things to try. Oops. All right. Do we want to just start at the beginning of the list and work our way through? Yes, no, maybe so. Start with positive, negative 1. I have a bunch of negatives here, so I can't use that same trick that I used last time that I did. So let's, I guess, just start with 1. When I look here, I do have 4, 3, 2, 1, 0, so I don't have to add any numbers in. Negative 3, negative 8, negative 12, and negative 5. The negative 3 comes straight down. One times negative 3 is negative 3. Negative 8 times negative 3, or sorry, negative 8 plus negative 3 is negative 11. 1 times negative 11 is negative 11. So these I can tell because I have a 1 here. These are going to keep getting more and more negative, right? That's going to be negative 23. That's going to be negative 35. And that's going to be negative 40. So I'm still going to be looking for a negative on this one, right? So that way I can get some positives down here to cancel out with these negatives. So that one doesn't work. Let's try negative 1. Negative 3, negative 8, negative 12, negative 12, negative 5. This doesn't work. I might have to go to another row if the next one after that doesn't work. My negative 3 comes down. Negative 1 times negative 3 gives me my positive 3. Negative 8 plus 3? Negative 5. Negative 5 times a negative 1 is a positive 5. Negative 12 plus 5? Negative 1 times negative 7 is a positive 7. Negative 12 plus 7? And negative 1 times negative 5 is a positive 5, which gives me 0. So that means x equals negative 1 is a solution, and that means x minus a negative 1 is a factor. Okay? So then, since this is x to the fourth, now I'm going to have x to the third, x squared, x, and x to the 0. So now I'm going to work with negative 3, x to the third, minus 5, x squared, minus 7, x minus 5. And because it's cubed, we do the guess and check again with the same values, or with new values if these changed. But if you notice, I still have a 5 on the end and I still have a 3 in the front. So I'm still going to have the same a sub 0. My a sub 0 is 5, which means my p's are still 1 and 5. And this time I'm not looking for an a sub 4, I'm looking for an a sub 3, but it is 3, which means my q's are still 1 and 3. So my possible zeros are still the same, p over q, which is going to be 1 over 1, 1 over 3, 5 over 1, 5 over 3, positive, negative, positive, negative, positive, negative, positive, negative. But now here's the thing. If positive 1 didn't work in the first one, positive 1 is not going to work in the second one. So I can immediately start with negative 1. If it didn't work the first time, it's not going to work this time. So I'm going to try negative 1. And then this time, I'm only going to have negative 3, negative 5, negative 7, and negative 5. I'm not going back to that negative 3, negative 8, negative 12, negative 12, negative 5. So no guarantees this negative 1 will work. If it does work, we'll talk about what it means if it works twice. Okay? It doesn't always work twice, but sometimes it does. So if it works, we'll talk about what that means. Or if it doesn't work, we'll still talk about what that means so you know. Negative 3 comes down. What's negative 1 times negative 3? Positive 3. Negative 5 plus 3? Negative 2. Negative 1 times negative 2 is positive 2. Negative 7 plus 2? Negative 1 times negative 5? And negative 5 plus 5? So it worked again. So that means that x again equals negative 1. So if it equals negative 1 twice in the same problem, since it equals negative 1 again, that means x plus 1 is a factor twice, or we can say x plus 1 squared is a factor. Does that make sense? Because it works twice. Okay? We are not done, because now, remember, this was x cubed. Now we're down to x squared. So now I have negative 3x squared minus 2x minus 5. That is a square. So I can check it to see if it factors. If it doesn't factor, then I use the quadratic formula. So I have a negative 3 and a negative 5, so that's going to be 15 in the top and a negative 2 on the bottom. So my factors of 15 are going to be 1 times 15, 3 times 5, and that's it. I want to get a positive 15. Can I get a negative 2 and still get a positive 15 when I multiply? Because I could get a negative 2 if I make this a negative, right? 3 times a negative, or 3 plus a negative 5 gives me a negative 2. But 3 times negative 5 doesn't give me a positive 15. So while it kind of is deceptive, you think it's going to factor, it doesn't. Which means quadratic formula. Yay! Quadratic formula, negative b. B is a negative 2. So negative 2 is positive 2. Plus or minus the square root of b squared. Negative 2 times negative 2 is 4. Minus 4a. A is negative 3. C is negative 5. All over 2a. Oh, we know what a is. A is negative 3. All right, let's simplify. 2 plus or minus the square root of 4 minus, let's see, minus, so I'm going to be negative. 4 times 3 is, I'm going to do 4 times 5 because that's 20, and 20 times 3 is 60. I try to multiply so it's easy in my head. And then on the bottom, 2 times negative 3 is a negative 6. So this is 2 plus or minus the square root of negative 56 divided by negative 6. Square root of 56, I'm going to come over here and do the square root of 56. 56 is divisible by 4. 52 is 13, so 56 would be 14. So that's 2 square roots of 14. Could we not be packing up already, please? So it's a negative 56, so a negative 4, which means I'm going to have the square root of 2i, or I could put the I on the end. So when I write this, it's really 2 plus or minus the 2 square root of 14i over negative 6. And then I split it apart, so I have 2 over negative 6 plus or minus 2 square root of 14 over negative 6i. 2 over negative 6 is a negative 1/3 plus or minus. Now this negative 6 just turns that one to a negative and that one to a positive, so it stays the same. 2 over 6 is 1/3, so square root of 14 over 3i. That's my second solution. So my solutions are x equals negative 1. My zeros are x equals negative 1. And then these two, negative 1/3 plus the square root of 14 over 3i. And negative 1/3 minus the square root of 14 over 3i. I'm going to write my factored form. If the bell rings, you might want to still copy it down. So my first factor is x plus 1, but remember that happened twice, so it's squared. And then x minus a negative 1/3, so plus 1/3, minus square root of 14 over 3i, x minus a negative 1/3, so plus 1/3, minus this negative fraction, so minus a negative is plus square root of 14 over 3i. Hey, look, I finished it right in time. We'll pick up with 39 tomorrow. We'll do 39 tomorrow. Okay?